Hi everyone, we're going to find critical numbers for f, find open intervals where f is increasing or decreasing, and apply the first derivative test to identify all relative extremum. So I'm going to first apply the first derivative test, and you get negative 4x plus 4. And you set this to 0, and you're going to get x equals 1. That means x equals 1 is our critical number. Since this is a polynomial, we know our domain is all real numbers, but since we have a critical number, that's where we're going to use our test numbers. So for my test intervals, I'm going to go from negative infinity to 1, because 1's our critical number, and 1 to infinity. And I'm going to test numbers for our derivative, and our derivative was a negative 4x plus 4. So say if I plug in 0, because 0 belongs here, I'm going to get negative 4 times 0 plus 4. That's going to be 4. And if I plug in negative 1, we're still going to get positive, and the numbers are going to keep getting higher. So our derivative is going to be positive because our numbers are positive. However, in this one, if I plug in, say, numbers like 2, so if I plug in 2, this is going to be negative 4. So any of these numbers in this interval, our derivative of x is going to be negative. Therefore, this is increasing interval, and this one is decreasing. And so we can write increasing on negative infinity to 1, and decreasing on 1 to infinity. And then for, I'm going to use my critical number 1 here, plug it back into my original equation. F of 1 equals negative 2 times 1 squared plus 4 times 1 plus 3. And that's going to give you 5. So when we plug in 1, we get 5. 5 occurs in this interval here, where it's increasing and then decreasing. So basically this is going to be a relative maximum. Relative maximum. Thank you. Have a nice day. Bye-bye.